types of volume measurements. First thing we'll look at is the average annual daily traffic. Daily traffic noticed by AADT. The average annual daily traffic is the average 24 hours or 24-hour traffic volume at a given location over a full 365 day. That is, we're talking about the total number of vehicles passing the site in the year divided by 365. We refer that as total number of vehicles passing the site in a year divided by 365 because we have 365 days in a year. So the next one we will look at the next parameter, which is the average annual weekday traffic. Average annual weekday traffic. So we'll call this AAWT. So what do we mean by this? This is the average 24-hour traffic volume occurring on weekdays. The average 24-hour traffic volume occurring on weekdays excludes weekend over a full year. So we can compute this by dividing total weekday traffic for the year by 260, because we have a total of 52 weeks multiplied by 5 weekdays. 5 weekdays. Why is it 5 weekdays? For each week we have between Mondays, Tuesday, we have Wednesday, we have Thursday, and we have Friday. So we have Friday, so we have a total of 5 days in a week multiplied by 52 weeks in a year. This will give us the average annual weekday traffic. The next parameter we will look at, the third parameter we will look at, is the average daily traffic. We call this the AADT. So the AADT is the average 24 hours. We call it the average 24-hour traffic volume at a given location for some period of time less than a year. Or 1 year. It will be measured for 6 months, or a season, a month, a week, or as little as 2 days. Be determined or measured for 6 months, a season, a month, a week, or as little as 2 days. So next we look at the fourth parameter, We're talking about the average weekly traffic. Average weekly traffic. We call this the AAWT. So what do we mean by the average weekly traffic? We said an average weekly traffic is an average 24-hour traffic, an average 24-hour traffic volume occurring on the weekdays for some period of time, less than a year of time, less than a year, such as a month or a season. The next parameter we will look at, or the next topic we will look at, is fundamental relationship of traffic flow. Fundamental relationship of traffic flow. Okay, next. So what we are going to define here is, the first term is, we look at time and speed. We denote it by V subscript T. As noted earlier, the time in speed is the average of all vehicles passing a point over a duration. The average of all vehicles passing a point over a duration. So all vehicles passing a point over a duration, so of time, it is the simple average of spot speed. So the time and speed denoted by Vt or V subscript T is given by V subscript T is equal to summation of I subscript I is equal to 1 and multiplied by Q I V I over summation of I by N is equal to 1 multiplied by Q subscript I equal to 1. This is 1. So this is given by V subscript T is equal to 1 over N, the reciprocal of N, multiplied by summation of I is equal to 1 VI. This will form our next equation, and start this at equation 1 for this topic, where V, here we said where V is the spot speed, V is the spot speed of the ith vehicles, and N is the number of observations. In many speed studies, speed are represented in the form of a frequency table. Then the timing speed will be given us. If we're using frequency table, our timing speed will be Vt, V subscript T, will be equal to summation, we have N, I is equal to 1 multiplied by Qi V I over summation N I is equal to 1 multiplied by Qi. So this will form our equation 2 for this topic, where we have where QI is the number of vehicles having speed VI, and N is the number of such speed categories. So the next thing we will look at is the space mean speed. Talked about this earlier. For this time, fill in the board so that we can define it properly. The space mean speed also averages the spot speed, but spatial weightage is given instead of temporal. Consider unit length of a road. Have a unit length of road. The spot is the unit length of our road, and let V be the spot speed. Let V equal to spot speed of the ith vehicle. Let T I be the spot speed of the ith vehicle. The spot speed of the ith vehicle. Call it the spot speed of the ith vehicle. Call V the spot speed of the ith vehicle. Let T be the spot, the time. Let T be the time, or this the time the vehicle. Okay, let's make it clearer. Let Ti equal to the time taken, time the vehicle takes, we call it the vehicle takes to complete unit distance. To complete unit distance, let Ti also script I be the time the vehicle takes to complete unit distance. The vehicle takes to complete unit distance, and is given by I, that is the reciprocal of VI, 1 over reciprocal of V subscript I. Then we clear the board for more working space or writing space. So it takes to complete unit distance, and it's given by, so it's given by 1 over VI. Then if there are such vehicles, then the average travel time T subscript S is given by TS is equal to summation of Ti over N, and is equal to 1 over N summation of the reciprocal of the I. So this will form our equation 3. So clean up the remaining space so that we can have more writing space. So if T average, subscript average. V is the average travel time, then the average speed, Vs, is equal to 1 over T subscript X. Vs is also given as N over summation of I is equal to 1, summation of N, I is equal to, where I is equal to 1, multiplied by 1 over Vi. This forms our equation 4. This is simply the harmonic mean of the spot speed. If the spot speeds are expressed as a frequency table, we will now have Vs will be equal to summation of N equal to 1 multiplied by Qi over summation of N, I is equal to 1, Qi over multiplied by Qi over Vi. So this is our equation 5, number 5, where Q is equal to a Qi vehicle, we have Vi speed and Ni in the number of such observation. So here we call Qi to be Qi vehicle have Vi speed and Ni is equal to number of observations. The next, we'll take an example to illustrate what we've said so far. Let's clean up the board. Let's take example 1. Example 1, we change the color of our marker. Something else, let's use green. We'll call this example 1. Example 1. Here the question says if the spot speed R is spot speed are 50, 40, 60, 54 and 45, then has to then find the timing speed and displacement speed. Speed and space speed. To find the timing speed and the space speed. So we are given different values here. The spot speed are 50, 40, 60, 54 and 45. So let's try to solve this solution. Where the timing speed Vt is the average of spot speed. So time in speed Vt is the average of the spot speed. So call it Vt is equal to summation of Vi, where Vi is spot speed, number of observation over N, which is number of observation. So here what we do here is we add all this, see our spot speed, plus 40, plus 60, plus 54, plus 45, over number of observation. We have 1, 2, 3, 4, 5, we have 5 observations. Divide this over 5, so this should be equal to 249 over 5. So the timing speed is equal to 249 divided by 5, which is 49.8. So the space mean speed is the harmonic mean speed, or the harmonic mean of the spot speed. So for us to calculate the space mean speed, so the space mean speed is the harmonic mean of the spot speed, mean of the spot speed. So what we're going to do here is we've gotten our timing speed, the first parameter. For the second parameter, we will clean up so that we can free up more space for write-off. So goes there. We want to get the space mean speed. So here ds is equal to Cn over summation of 1 over vi, and this is equal to our observation is 5 over summation, the add up 1 over vi, so it's going to be reciprocal 1 over 50, which is this, plus 1 over 40 plus 1 over 60 plus 1 over 55. So when we sum this, it will give us 48. We'll have 48.82. So this will give us equal to 48. So that is the space mean speed. So we call this space mean speed. For the timing speed, we are able to add up our spot speed and divide it by 2. But for the space mean speed, we will have to get the harmonic mean of the spot speed. Here we divide n, which is n is 5 over summation of 1 over the spot speed. So we have 48.82. Next, we take another example. Example 2. Question says the result of the speed study is given in the table. From a frequency distribution, or is given in the table, which is the frequency distribution table. Call it frequency distribution table. To find timing speed and space mean speed. So we're asked to find timing speed, and the space speed. So from the frequency table, what we have here is speed, or speed range, and we have frequency. So I'll try to do this. So speed range, so have here frequency, so try to get the values. We have 20 to 2 to 5, I have 6 to 9, I have 10 to 13, then we have 14 to 17. So our frequency is 1407. So how do we solve this? We have to plot a table. So we'll tabulate this, put it in a tabular form in order to be able to solve it quicker. What we need to do here is, on our table, let's place this figure close by. We place it close by so that we can accommodate our table for calculation. So what we need to do here is, for the speed range, and frequency, our speed range, and we have our speed range here is 55, 6 to 9, 10 to 13, then 14 to 17. So our frequency, as we said earlier, is 140.7. So we tabulate this. So we can always use lines to make it easy for ourselves. We make a tabulation. This, then we'll have this. There's another column. So we'll have this. We'll have our last one. So we'll have this. So we'll be able to draw the table. The first thing we need to talk about the speed range. Then we have average speed, which is denoted by V subscript I. Then we have volume of flow, which is Q. Volume of flow, which is Q, flow, denoted by Q, I. Then the next thing we have is a product of VI, QI. And the next thing is QI, VI, denoted by VI. So what do we need to do here? We have our first trial. We have about how many trial? 1, 2, 3, 4. So this is serial number 1. Call this 1, 2, 3, 4. So we use this. So from our table we have here 2 to 5. Okay, before we do that, let's conclude our lines. I have this, I also have this. Okay, so the total of what we have now, we going to wipe off this. So what I have here is we have 2 to 5, not 2 to 5 from the table. We have 6 to 9. We have 10 to 13. We have 14 to 17. So we take the average of this. We have this plus this, which is 7 divided by 2. This will give us 3.5. The very one we have 6 plus 9. This is 6 plus 9, which is 14. Which is 6 plus 9 is 15. Beg your pardon. So this is 15 rather than 14 divided by 2. This should be 7.5. Next we add this to this. We have 10 to 13. This will be 23. 23 over 2. 23 over 2. This should be equal to 3 over 2 is the same thing as 11.5. Then the next we have 14 plus this, which is 31 over 14 plus 17, which is 31 over 2. This will be equal to 15.5. So we have 15.5. So from the table, this is our volume of flow, which is the frequency. So we're going to write it out. Volume of flow. We have 1, we have 4, we have 0, we have 7. So we multiply VI by QI. This is VI by QI. So this is going to, for this we have 3.5 multiplied by 1. It's going to be 3.5. So here we have 7.5 multiplied by 4. This is 20. We have 3.5, so we have 7.5 multiplied by 4. This is by 2 is 15, by 4 is 30. Then we have 11.5 multiplied by 0. This is 0. Then next we have 7 multiplied by 15.5. This will be equal to 108.5. 108.5. Go check that in your calculator, or you can run a calculator out to be able to get what we want. Pick an application calculator to grab the calculator. So stick up our calculator here to confirm what we're doing. So here we have this. So this we have this. So we can confirm what we've done. 15.5 by 7. 15.5 by 7. See what we have here. We have 108.5. The next thing we need to do is to divide this by VI, that is QI by VI. Let's divide QI by VI. So our QI is already given here. This is QI by VI. So 1 divided by 3.5. What do we have? 1 divided by 3.5. this to be equal to 0.28 0.28. So we have that as our VI. So 1 divided by, we have our QI over VI. Our VI is 3.5. So we have that. So this is what we have here, 0.29. 0.29. So we'll continue with our calculation. 0.29. For this one, we have QI over VI, 4 divided by 7.5. So we divide 4. We divide 4 by 7.5. Here we have 4 divided by 7.5. So we have our answer. We have 0.54, 0.533. 0.533. Then for the next parameter, what we'll have here is 0 divided by this, which is 0. The next one we have 7 divided by 15.5. It says 7. Cursor. It says 7 divided by 15.5. So we'll have here is 0.45. So we'll have here is 0.45. So the next thing we need to do is we add up all our figures to get the total. So what are our figures? So we have gotten 0.45 plus, try to add it. We have our plus 0 plus 0.5 0.533 plus 0.29. So we have error, so let's add that again. 0.29 plus 0.533 plus 0.29 or 0.45, which is the last one here. So we have this is equal to 1 point, this should be total of total equal to 1.273. So it means the calculator. So the time mean speed and the space mean speed can be found out from the frequency table like the one we have here. That the average speed is which is the mean of the speed range. For example, for the first speed range, the average speed we have shown on the table, which is this plus this, which is equal to 7 over 2, 5.5. The volume of flow QI or Q suspect I for that speed range is same as the frequency. So the terms VI QI and QI VI are tabulated in the table. So we've seen what we've done on the procedure of what we have there on the table, how we're able to complete the tabulation or the values on the table. Their summation in the last row. So the time and speed can be computed as we have our view. We can clean this question so that we have a working space. So our time and speed, we have asked to find both the time and speed and the space mean speed. So how do we compute the time and speed? Here we have the time and speed can be computed, and the speed is equal to, given by Vs is equal to summation of Q I, also script I over summation of QI over VI over VI. Here we have this script I, and this is equal to, we have summation of QI is a total of 1 plus 4 plus 7, which is equal to 12. So the total of this one is 12. So we have 12. While summation of all these, we got 1.27. 1.27. So this will be equal to, this is space mean speed, not the time, I beg your pardon, space mean speed. So we divide this by, this is QI, so summation of QI over summation of QI over VI. So this will be equal to 12 divided by 1.27. Write our calculator out again. Stick it. So let's see what we have here. We have 12 divided by 1.27. This should be equal to, so we have this as, this will be equal to 9.488, approximately 9.49. So for the timing speed, because we're supposed to get timing speed first, so since we have done that for space mean speed, we will now do that for timing speed. Time speed is given by, or denoted by, summation of QI VI over summation of QI. Okay, so this will equal to QI VI. Remember, we have QI VI. The total here is what we are going to sum. The total here is, let's see from our calculator. Let's drag the calculator off using our cursor. So we're going to sum that. Summation of these, which is summation of everything we have here. So this will be equal to, we're going to have total of 12.5 plus 30 plus 108.5. 8.5, this will be equal to 142. So write this down. 142 over, here we have QI. Summation of QI is what? Here we have our 12, which is 1 plus this 5 plus this, which is 12. So this will equal to 11.83. So this is the timing speed. So this is calculator. We'll have to see what we're doing. So this is the timing speed. Why this is the space mean speed. So viewers, this is where we come to the end of today's lecture on volume, measurements of volume of traffic. We call it types of volume measurements. So measurement of volume, or we're looking at types of volume measurement, which we talk about the AADT, which is average annual daily traffic, average annual weekday traffic, which is AAWT, average daily traffic AADT, average weekly traffic, which is AAWT. And we look at also the fundamental relationship of traffic flow, where we talk about the timing speed and the space mean speed. And we ended this lecture by looking at 2 examples, one involving a simple calculation and the second one which involves the frequency, use of the frequency table. So if you need to subscribe to our channel, please do so by hitting the subscribe button, turn on the notification icon, so whenever we post a new lecture or new video, you will receive updates. Give us some thumbs up if you like this video. I still remain Engineer One. Thanks for staying with us. Bye for now.